So small interruption. Okay, Karthik, you can see and hear me.
Yes, sir.
So next is going to be binary to hexadecimal conversion. Now you can predict this thing when the number of digits were when we came from octal to binary, or from binary to octal. That time we did groupings of three. So in hexadecimal, the maximum number is zero. The minimum number is 000, and maximum is 1. So this is the number 0, and this is the number f. So how many bit grouping are we expecting now? 4 bit. So let us start with a slightly bigger number. It is important to note that binary to hexadecimal will reduce the number of digits. So it will make the code short. Again, we start from the right side, and you can see I have done groupings of 4 now. So here we have done groupings of 4, of course from the right side. So first one is 1001, then you have 100, then 1000, 1101, and that's what has come all the way here. So if you look at 1011, now from the conversion table, you should be able to tell me that 1011 is nothing but 11, but there is no such thing as 11, so it will be B. So 1009, 1001 is 9, 1000 is 8, 1101 is actually 1101 is actually 13, but that is going to be C. Sorry, D. That is D. So what is the answer? This in binary is equal to this in hexadecimal. So here you will have to write 16, not 8, it will be 16. Or you can also write that this is equal to D89B. So some books will write here H. So either you can write 16 or you can write H. Both are one and the same thing. So this is something that we have to follow. So next is obviously hexadecimal to binary. So we have a smaller number. Now we are planning to make it slightly bigger. So for 3, the binary code from the table is 0011. For F it is 111, and for D it is going to be, can you guess, 1101. Just now we saw that. So we just arrange that in the proper order. 3 is this, F is 4 ones, and D is 1101. And when you just combine it, what you are going to get is the hex to binary. So this is what is this. So sometimes, many times in the exams, they may write 16 or they may write 8. So don't get confused. So in the exam, they may also give you convert this like this into binary. So H means 16. Okay. So these two conversions are pretty simple, from binary to octal and octal to binary, and the other one is binary to hex and hex to binary. The next thing is going to be, what if we want to directly convert from octal to hexadecimal or hexadecimal to octal without involving binary. So this is something that we want now. Before we go ahead, some of you may have doubt. What if there is a floating point? So this is an example with floating point. And what we are again looking is hexadecimal to binary. So, okay. So please observe what I am doing. 5A9.B4. So what you do is just write the binary of 5, binary of A, binary of 9, and binary. There is no binary of floating point. So we write the floating point as it is. Then B, and then 4. Then combine it. So I'm removing the spaces from here, and I get the left side of the floating point. I remove spaces from here, and I get the right side of the floating point. And the floating point is maintained. The position of the floating point is maintained. So the answer would be 5A9 B4 in 16 is all this with a floating point position maintained and all the binary bits on the other side. Now please don't skip these bits just because they don't make a difference, 0 and these three zeros, don't skip them. You have to write them as it is. Okay. Now the next one is octal to hexadecimal. So can you see, till now whatever we have done, it involved some kind of binary in it. That means binary was common everywhere. Now we want a direct conversion from octal to hexadecimal. So what should we do? Let's start it again with a number. 6 is an octal number. 6, 1, 5 all are between 0 and 7. Step number 1. Convert octal to binary first. How do we convert octal to binary? Just write the binary equivalents. First of 5, 101, then 001, 110. Then I am removing the spaces and combining all of them together. And now we do groupings of 4 because octal talks about grouping of 3 and hexadecimal talks about grouping of 4. But grouping can be done only if I have the binary equivalent. That is why in between the first step is always going to be calculation of binary. So that's what we do. This is step number 2, that append. So we are starting from this side. 1 1. So here 1 1 1, it was 101 001 110. Now I am grouping 4 bits together. So can you see this 1 bit gets included in this number? So that is 1101. Then we have 1000, and this 1 is left alone. So this is just having 1 bit. Now hexadecimal means we have to do grouping of 4. So what should we do? So like I have already shown here, you have to append zeros to complete this 4 bit, or 4 bits is also called as a nibble. So 2 nibbles will give me a byte. 2 nibbles means 8 bits we generally call as a byte. But anyways, we are long from byte, the word byte, but since we are talking about grouping of 4, so grouping of 4 is also called as a nibble. So what I have done, I appended these 3 zeros and completed this 4-bit grouping. Now I am ready to convert 1101 to hex. So 1101 is going to be 13 and 13 is B. 1000 is 8. 0001 is 1. So somewhere you are expecting 18B. You can see here that we have 18B, that is convert from binary to hexadecimal. So if you want to convert from octal to hexadecimal or vice versa, you have to do two steps: convert octal to binary and convert binary to hexadecimal. So this is something that we have already seen in as before. So how will you write the answer? 6158 is 18B 16. And now we will look at the final code, that is conversion of hexadecimal to octal. So my first question is this a hexadecimal number? If yes, then you type yes in the chat box. Is this a hexadecimal number? Okay. So now I think from your replies that you don't have any doubt whether a number is hexadecimal or octal or binary. So because the response that you give is super fast, so I think everything is there in your head. I would like everybody to participate and respond so that I can do some changes if somebody is not understanding. So first step again will be convert hexadecimal to binary. This is the binary of 25B. I am removing the spaces and then I am doing, now we are going from what, hexadecimal to octal. So we are going from 4 to 3. So we have to now do grouping of 3. So this is the grouping of 3. Now naturally here we did not have to append any zeros. Now you should understand why, because uh, here there are 12, this is 4 bits, 4 bits and 4 bits. So in all there are 12 bits. So obviously 12 is exactly divisible by 3, and that is why you got 4 3-bit groupings. So that is why there is no need to append zeros. But as a general step, if you get something here, if you get something more here, let's say something like this, then you have to again append zeros for this zero. So that is required. And then you convert this binary to octal. Since you have grouped in 3, you can, so 011 is 3, 011 is again 3, 001 is 1, 001 is 1. So this is the way to convert hexadecimal to octal. Now I want you to tell me what will be the conversion of 25B point 38 in hex. I want you to convert that into octal. So quickly tell me the answer. So post the answer in the chat box. Karthik, Anushka and Kashmir, are you able to hear me and see the screen properly?
Yes, sir.
Yes, sir.
So how will you solve this? So see 25b is already here. 25b 0.38. So we already know that what is this 25b? 1133. Now all we need to look at is this side. So 3 is going to be 0, 1, 0, 0, 1, 1, and 8 is going to be 1, 000. So now we will do grouping of 3 and append one 0 here because 8 is not exactly divisible by 3. So here we will have 0, 0, 1 is 1, 1, 1, 0 is 6, and this is 0. So this side we have already calculated. What is that? 113. So it should be 1133.160. Great. Karthik, you have written 113.16. You have to add a 0 to it. If you don't add this 0, then the answer would be wrong. Even Deepak, Ashlesha, I told you that you have to do grouping of how much? Grouping of 3. So here this will consume 3 bits, this will consume 3 bits, but then you have to append one extra 0 here to complete these 3 bits. Even Sanchit, you have to add one extra 0 there. It is 113.160. Okay, so please understand the key points are do grouping properly, and if 3 or 4 bit grouping is not possible, then you append zeros to complete group of 3 bits. So that is the key point here. So how will you write the answer? You can write 25b16 is 1138. Okay. Now Raj has asked a question. Sir, why we take 3 bits only in octal? So in octal, I'm just explaining it here. We have 7 digits, 0 to 7. So in all there are 8 digits. So 8 means 2 raised to 3. So that is why each digit can be represented using 3 bits. Have I answered your question, Raj? You can unmute and yes.
Yes, sir.
Or is there a doubt?
No, sir.
So 3 bits means you have to go from 000 right up to 111. That is the maximum that you can get. Okay?
Yes, sir.
Okay. Good. So I want people to ask doubts, which is very good. So Raj, I have also noted one doubt which Vishwas has asked me in the last class. What about the negative sign? So today I am going to highlight on that. Now everybody should write this. That is the next part, that is binary arithmetic. So this is something new for you now. Now binary arithmetics mainly deal with binary sum and binary difference. So many times we have to add and many times we have to subtract. You may have question, what about multiplication? And you may also have question that when you talk about arithmetic, we have studied division also. So as far as digital is concerned, multiplication is many times addition and division is many times subtraction. So that is why we are looking at sum and difference, and all the circuits are based on. So if you are doing, if you are looking at a multiplier, it will have many adders. If you are looking at division, even that will have adders. Now why I will tell you, in digital, for addition you require adders. For subtraction, what we do is we use two methods actually. If you are going to see today, that is one's complement and two's complement. Then we add. So basically, addition is addition only, but even in subtraction, we are using addition. So basically, what happens that if you want to do any arithmetic operation using digital circuits, we will have to use adders, and speed of the system will depend on how fast the addition is being done. So it all comes down to adders. So that is why in the digital literature, you will not see much of subtractor or multipliers. Multipliers you can see, not of the divisions you will not see, because in some or the other way, each operation is an addition operation. Now I will put more light on this as we progress ahead. So let us start with binary arithmetics. There are two things in that we are going to see. That is binary sum and binary. Let us look at first the sum part of it. So I want you all to copy down this table and remember this for the entire course. It is not very difficult, it is very easy. And I'll give you the explanation for that. So I'll give you 2 minutes to write this. Karthik and Anushka and Kashmira, once you are done with it, just let me know. So have you all copied this table? It's a very simple table.
So,
There are two inputs.
so,
Yes, Anushka.
so where here there are like two. There are A and B, and then some in carry. So what is carry actually?
Yeah, so that is what I have explained. First, just copy down the table, then I will explain this thing. So I think you must have copied it down. So let me start the explanation
Yes,
as we
sir.
write. So first we need to add 0 and 0. So what I'm going to add is 0, 0. So 0 plus 0 is going to be 0 in any sum. So that is what we will write here. This is my A, this is my B. So this 0 is going to be my sum, and there is not going to be any carry because the sum itself is 0. So there is no digit produced which is greater than 1. So that is why the carry is 0. Now next combination. So that is why I am writing here carry is 0. Next combination is 0, 1. So if you add 0 and 1, what you will get is sum is going to be 1, and you don't get any number which is greater than 1. That is why again carry is 0. In the second case, in the third case, again if you add 1 and 0, what you are going to get is the number 1, which is your sum, and again you don't get anything which is greater than 1. So again carry is 0. Now what happens is, the fourth case will explain it all. Now you may ask me, what is happening here? 1 plus 1 is 0. How? Let me give you one example. Let us say if I tell you to add 7 plus 6. So what do you write here? What is 7 plus 6? I am sure you all know it's 13. Okay. But how do we write? We write here 3, and that extra 1 is we are going to write it here. Right? Why do we do this? 7 plus 6 is 13. So why do we do this? Why don't we write simply 7 plus 6, 13? So this is 1's place, this is 10's place. Because the place value of this is just 1. It cannot accommodate this additional 1 here. So that is why we put that 1 from here to the 10's place. Similarly, in binary, what happens is, actually what is 1 plus 1? 1 plus 1 is 2. But in binary, we have only 2 digits, that is 1 and 0. So we cannot write 2 here because it is an invalid number in binary. So what do we do? I want to 1 plus 1 is 2 only. But how do I write it? I'll write here 0, and here I'll say carry is 1, and I'll write that 1 here. Now actually if you see 1, 0 in binary, what is it in decimal? It is 2 only, right? 1, 0 in binary is 2. So actually in the addition you got 2, but when you had to write an 0. That is why the sum comes to be 0 and the carry comes out to be 1. So Anushka, does that answer your question?
Yes, sir.
So let us say that you have bigger numbers, like for example 13 plus 14, let's say. So 3 plus 4 is 7, 1 plus 1 is 2. Now you can simply write this because both are, these numbers are a part of decimal number system, 2 and 7. But 13 was not a part of decimal number system. So that is why we had to put that 1 in the 10th place simply to represent 13. Similarly here, 1 plus 1 is 2, but there is no 2. We have only 0 and 1 in binary. So how to represent this 2 using 0 and 1? Like this, 1, 0. So I have to create, so this was 2 raised to 0, this was 2 raised to 1. So that is why this place is going to be 2 raised to 0, this place is going to be 2 raised to 1. So that's the logical way to write in terms of sum and carry. So there can be many sums, we can have many sums, but in the end we will have only one carry. So if the number is big, then we may have to carry here, add again, carry here, add again, carry here, add, and then finally get one final carry. So we will look at this thing through examples. So next is binary difference. Now obviously same thing, 0 minus 0 is going to be 0, so difference is 0, borrow is also 0. So difference is 0, borrow is 0. Next case, A and B is 0, 1. So 0, what is 0 minus 1? 0 minus 1 is minus 1, right? Now, how do you represent that? So the difference between 0 and 1 is 1 only. The difference between 1 and 0 is also 1. But when you are subtracting a higher number from a lower number, that time the borrow is going to be 1. When you are subtracting lower number from a higher number, that is 1 minus 0, that time difference will again be 1, but there will not be any borrow. So what I mean to say is, let us say if you are doing like this, 13 minus 9. So what you actually do is, you cut this and you write 0 and you write here what? 13. So how much did you borrow? You borrowed 1, right? And that is what we did here also, that when you are subtracting from the next place value. So that is the essence of it. So I'll just show you this. Your difference is 1, borrow is 1. In this case, difference is going to be 1, but borrow is going to be 0. And finally, what is 1 minus 1? 1 minus 1 will be 0 only, and there is no question of borrow. So that is why borrow is 0. So I want you to copy this table also. So please copy this table. And Anushka or Karthik, just let me know once you draw this table. So there are two tables that we have to draw. One is for binary sum and one is for binary difference. We don't say subtraction in binary, we say sum and difference. Difference is different. Difference means absolute difference. That means here 0 minus 1 is 1. The difference is 1, and 1 minus 0, again the difference is 1. Okay, any doubts in this, please ask. This is going to be our fundamental. We will not be using this difference table much, but we will definitely be using our addition table. If anybody has a doubt, they can unmute and ask.
Sir, in the difference table, the borrow was 0. I couldn't get it.
The difference, the borrow was 0. For which case? The first case?
The last case.
The last case, for 1, 1. So let's say that we have 1 minus 1. So which are the 1 represents 1 in binary? If this is, let's say, 2 raised to 0, this is 2 raised to 1. So 1 is having its absolute value here. So 1 minus 1 would be 0, and there would not be any, we would not borrow anything from here to here to do this subtraction. That is why my borrow is 0. But if I would be doing this, then I will have to borrow something from here to here. That is what I borrow is to do this minus this, 1 minus 0. Again, I don't have to borrow anything from here to here. That is why again borrow is 0. And similarly for 0 minus 0, again I don't have to borrow. So wherever you don't have to borrow from the next place value, there I am putting zeros. And wherever you have to borrow to do the subtraction, there I am putting 1. So have I answered your question?
Yes, sir. Thanks.
Good. Okay, so let's move ahead. I think this will be the end of this particular slide. Okay. Now, please understand that there will be like questions of around 10 marks on subtraction using ones complements or twos complement method. And this is going to, this ones complements and twos complements methods are going to be the fundamentals in our entire addition or subtraction processes. So I want you all to write down certain things, and I'm going to go slow in this so that you get some time to write. So first thing is, what is ones complement representation? This is not ones complement subtraction, it is just ones complement representation. So the ones complement of a binary number is the number which results when we change all ones to zeros and zeros to ones. Now, what is the meaning of this? For example, if you have this number 1101, what would be the ones complement of it? So this is your given number. Ones complement would be that 1 becomes 0. If it is 1 here, it becomes 0. Again, if it is 1, it becomes 0. If it is 0, it becomes 1. And if it is 1, it becomes 0. Now, though this is called ones complement, actually in digital design, we always say take complement of the number. We never say take ones complement, though it is actually ones complement, but we just casually say take complement of 1101, and complement of 1101 would be 0010. So don't complement and ones complement is not different. They are one and the same thing. If you want to take one more example, if you take a bigger number, let's say this is your given number. So first here 1 becomes 0, 0 becomes 1, 1 becomes 0, again 1 becomes 0, again 1 becomes 0, then 0 becomes 1, 0 becomes 1, 1 becomes 0. So just a simple check that I want to do in the chat box. What is the complement of 0, 0, 0, 0? So that's correct, all ones. And what is the complement of 111? It will be again 0. So what I mean to say here is that if you take one's complement of number 2 times, you will get the same number back. Okay, so point to remember, if you take one's complement of this, and if you again take one's complement of this number, that is 1 0 1 1 1 0 0 1. So you should see that this number and this number are going to be same. So basically this complement operation in digital design is done by logic gate inverter. It is done by what? It is done by the inverter. So that is, we will go to gates after this. So the gate which does this operation, that is taking complement, is a inverter. So if I want to convert 8 bits, if I want to take complement of an 8-bit number, I will require 8 inverters. If you are considering it doing parallelly. So that is why inverters are also is one of the fundamental entities in digital design. If an inverter is fast, then the complement operation will be fast. and if the complement operation is fast, the sum operations are also, the sum or the subtraction operations will also be fast. So we look at these things, and many people have proposed different kinds of inverters or different ways in which complement can be taken. So you can use these keywords to do or search your IEEE paper, which is going to be your final one of the assignments of this course, that is where to present one latest IEEE paper. So as and when I am saying in lectures, note some points so that you can also use the same when you go to your IEEE paper search. Next is two's complement representation. Now two's complement is 1's complement plus 1. So what is that? So again, let us take an example. So the example is 1001, which is this number. This is actually 9 in binary. So this is 1001. So first, what do we do? We will take 1's complement. So what is 1 complement of given number? 1 is 0, 0 is 1, 0 is 1, and then 1 becomes 0. So now you have taken 1's complement. But what I am looking at is 2's complement. So 2's complement is 1's complement plus 1. So I just add 1 to it. So from our addition table, 0 plus 1 is 1. Here you can consider all zeros. So 1 plus 0 is 1. 1 plus 0 is again 1. 0 plus 0 is 0. So I want you all to keep that addition table in front of you when you are looking at binary addition. So what we are doing is now addition. So this is the 2's complement of this binary digit. Okay, some more examples. Now can you all find out the 2's complement of this number? Find out the 2's complement of this number and post it in the chat box. Okay, so let's see. Many have posted it. Anushka, Sanmesh, Pratik, Sanjana, Yash. So how? This is your given number. This is the 1's complement. And when you add 1 to this, we are going to get, what is 0 plus 1? 1. And all these you can just take it as zeros. So 1 plus 0 is this, and finally you get the answer. So all of you, those who have posted, have given the right answer. Good. Okay, Apurva, Prathamesh, Tanvi has also given the right answer. Yes. Now I want you to tell me what will be the addition of 1011 plus 0111. Add this. Okay. Okay, Pranjali is the first one to answer that. 10010. Ashish also answered. So how? So I want you to just understand what is the like the principle behind this addition. 1011 and 0111. Now I you can look at the screen, but I want you all to go and look at the sum table, the table of sum. Now here 1 1 means the sum will be 1, but carry will be 1. So what if there are three ones? Then the addition of these two ones, 1 plus 1, what will it be? So the addition of these two will give me 0 and carry will be 1. So I'll write that carry here, that is 1, and this 0 and this 1 will give me 1 here. So when there are three ones, what will happen? The sum is also 1, the carry is also 1. Now if you want to look at this in terms of place value, when I actually add three ones, the answer is 3. So 2 raised to 0 is 1, 2 raised to 1 is also 1. So this is 2 plus 1 is going to be equal to 3. So when there are three ones, we will have 1, sum is also 1 and carry is also 1. Now again here 1 plus 0 is 1 and 1 plus 1 is going to be 0. So carry will again be 1. Again 1 plus 1 is 0 and carry is going to be 1. So I'll just write it here. So my answer now becomes 10010. Now I want to, before I go ahead, I want to clarify one thing. Those who have doubt in this triple ones, you can ask a question. I think I have clarified it, but still, if you have any doubt, you can ask. Does anyone have a doubt there? Those who have posted the answer, their answers are right. But those who have not, I want some feedback from them. Okay. What we'll do is, let's go to another number. So I want you to add 11101 and 101101. So add this and tell me the answer. Okay, again Pranjali is the first one to answer this. Oh, sorry, Deepak is the first one. And then Vishwas. Okay, so the answer is 7 bits. So let me just calculate that again. Okay, so what I'll do is this 11101 plus I want to add 101101. So if I add this 1 plus 1 will be 0, carry 1. So 1 and 1 will be again 0, carry 1. 1 and 1 will again be 0, carry 1. Now here you have three ones. So the first addition will give me 1 carry here and the answer will be 0. and this 0 and 1 will be 1. So in a way, carry is also 1, sum is also 1. 1 1 is 0, 1, and again 3 ones means sum is 1, carry is also 1. So your answer will be 1101 triple 0. 1101 triple 0. That's right. I guess everybody has a solving.
Excuse me, sir.
Yes.
So this is Gaurav Kumar. Can you explain this triple N thing once more?
Okay. I'll just create some space to type. Okay. So we have 1 1 1 0 1 1, and then we have 1 0 1 1 0 1. So this is something that we want to add. Now here 1 1 is, have you understood this 1 plus 1? 0, that is carry will be 1.
Yes, sir.
Okay. Now 1 plus 1 will be 0, carry again 1. So 1 plus 0 is 1, and then 1 plus 1 will be 0, again carry is 1. So now here you can see that there are three ones, 1 plus 1 plus 1. So if I sum this from the table, is the table there in front of you?
Yes, sir.
So what is the sum of this? 0.
0.
And the carry will be 1. So carry I will write it in the
One.
next place carry. But you sum these two ones, the first two, still this is pending. So what is the answer? Sum of the first two ones 0. Now 0 plus 1 would be what? 1. And carry you have already accounted for. So that is why the answer, the sum here will be 1 and carry also will be 1. Have you understood this?
Yes, sir.
And then this 1 plus 1 again will be 0, and here you will have 1. Again here there are 3 ones here. So the sum of these two as per our sum table is 0, and carry is going to be 1, right?
Yes, sir.
And then this 0 and this 1 will give me 1. So again this carry I will bring it down and write it here. So the answer becomes 1101 triple 0.
Yes, sir. Thank you, sir.
Okay. Yes. Anybody has a doubt, please ask. This is the thing which is very going which I'm going to use every now and then. That is why you should be clear with this. So let's do it like this. If you want, you can just make a table. 0 1 is 0 plus 0, or in the same table you can write, if there are 3 ones, 1 1 1, then sum is also 1 and carry is also 1. Okay, this is what you can just note. Okay, now we will see, we have seen addition. Now let's see subtraction by one's complement method. So I want you all to write down this. Subtraction means, subtraction always involves two numbers. One may one may be big, one may be small, or they both may be equal. In the case that they are equal, your subtraction result will always be 0. And if the numbers are big or small, your answer will be positive or negative. So what we will first see is subtraction of larger number minus smaller number. So the answer that we are going to expect is positive. So, method. First, determine one's complement of the smaller number. Then second, add the one's complement to the larger number. So you have to find out one's complement of each number, smaller number first, and then add this inside this. Remove the carry and add it to the result. So if you add something and if you get some carry, then you have to add it back to the result. So adding the carry back to the result is known as end around carry. Adding the carry back to the result is called as end around carry. So I want you all to write down these three steps. First you write subtraction by one's complement method, and then you simply write large minus small. Larger number minus smaller number. So should I wait for 2 minutes, Karthik, Anushka and Kashmira?
Yes, sir.
Okay, so once you are done, just let me know. So again, I am repeating. Step number 1 is determines one's complement of the smaller number. Add one's complement to the larger number. And if there is a carry, just add it back to the result. This procedure is called as end around carry. Okay, should we go ahead?
Yes, sir.
So even if you don't write this, it's fine. But once you write, this method will be stored in your head. That is why I am making you write this thing. Now we can go to an example which will make the thing very clear, and then probably you don't have to even remember these three lines. It will just be very intuitive for you. Okay, so let's look at an example. So the first example is, just write the sum, subtract 101011 from 111001. So in the exam, they will clearly write subtract this number from this number from this number. That means this should be the larger number and this should be the smaller number. So from the question also, you should be able to identify first which is the bigger number and which is the smaller number. And by looking at this also, you can identify that 111001 is basically a large number than 101001, because simply it has got a 1 year, which itself makes it large. So please copy this question first, and in your words you can just write how I have identified which is bigger and which is smaller. Okay, so let's go ahead. So this is what we have to do. Once you identify large and small, you clearly write in your own words or the way you want that this is what I am going to do. So this is larger and this is smaller. Now let's take these numbers one by one. This is my first number, that is the larger number, and this is my smaller number. Now, if you clearly read step number one, what is that we have written? Take complement of the smaller number. So, what do you mean by take complement of the smaller number? This is the smaller number. So, I took complement of it. 1 is becoming 0, 1 is becoming 0, again 0, 1, 1, 0, 0, 1, 1, 0. So, wherever there is 1, I am replacing it by 0. Step number 2 is add this complement, add the ones complement to the larger number. So I took this number and added it to the larger number. So this is what we have to do. So this is step number 2. Now I want you all to add this and tell me what is the answer. Come on. All of you should add this. Add these two numbers. Add this. Okay. Okay, great. So how do I do it? So in initial steps, I will just explain this. So 1 plus 0 is 1. 0 plus 0 is 0. Then 0 plus 1 is 1. So just keep the addition table in mind. 1 plus 0 is 1. Now 1 plus 1 would be 0 and carry would be 1. So again this 1 plus 1 would give me answer 0 here with a carry 1. With the carry 1. Now step number 3 says that if there is any carry, so many of you have this 1001101. I can see in the chat box. Harsh, Apurva, Sarvajna, Ganesh, okay, correct. Bruvali, Anusha, okay, answer is right. Now, step number 3 says add this to this result. Add the carry to the result itself. So this is called as end around carry. So if I add this 1 again back to the result, now tell me what is the answer. So please don't include this 1 now in this 6 bits. So you have to consider only these 6 bits now for addition. Sorry, here, and add 1 to it. So tell me the answer. Now tell me the final answer. Okay, great. So Parth has already reached Omkar. So this is 0, 1, 1, 1, 0. 0. So the answer is going to be 0, 0, 1, 1, 1, 0. Now, I want you to find out what are these numbers. So this is going to be the answer. So I hope you have understood. First we took one's complement of smaller number, added it back to the larger number, then we got some addition, then we observed the carry. If the carry was present, we had to add it straight away here. If carry would have not been present, then the answer would have been what it would have been. So this is the first thing. Let us look at another subtraction by one's complement. Now, yes, anybody has a doubt?
सर डेसिमल
Yes.
नंबर को सिर्फ हम लोग ने बाइनरी में कन्वर्ट किया है ना, नंबर तो वही है, तो डेसिमल का आंसर और बाइनरी का आंसर अलग अलग क्यों आ रहा है? मतलब डेसिमल से लिया तो दैट सम वाज 57 माइनस 20 इक्वल टू 37, लेकिन हम लोग ने जब कैरी लेके किया तो आंसर वाज 28
This is 57
and 20
and
20
20.
yes.
Okay. No, this is not zero. This is, I think you have done some calculation mistake here. It is more. This is not 20. This is something more. This is 9.
Sir, she is taking decimal equivalent of the ones complement. We have
Decimal.
to subtract.
This one. Now, which number are you exactly talking about, Pranjali?
सर कॉम्प्लीमेंट वन
No, don't look at that itself. It will not mean anything. If you are looking at this thing, it doesn't mean anything. So this is actually something like this is 8. So this will be 16 plus 4. This is 20, right?
यस.
So don't look at this number at all. We are not subtracting here. We are adding. We are not subtracting. We are adding. So this is okay. This is something else that we are talking about. Not relevant here. Means I didn't get your question actually. What is your question? This minus this should be this. That's what we are looking at. This is the
My
intermediate
question
step.
was, हाँ, my question was कि डेसिमल में सब्सट्रैक्शन करने के बाद जो आंसर आएगा, सॉरी बाइनरी में सब्सट्रैक्ट करने के बाद जो आंसर आएगा, अगर उसे हम लोग डेसिमल में कन्वर्ट करते हैं तो क्वेश्चन को
Yes.
भी और आंसर को भी, तो आंसर सेम आना चाहिए.
Yes, so but you have to calculate decimal of this and this, not this. What you are doing is you are calculating the decimal of the complement. You, while actually subtracting in decimal, you have to calculate decimal of this and decimal of this. Then you will get some answer. That is this answer. Are you understanding what I am saying?
Yes, yes.
What you are doing is you are taking decimal of the given number and you are taking decimal of the complement, which is wrong. You have to take decimal of given number only. Okay. So I hope I have solved your doubt.
Yes.
This is an intermediate step. So if you try to subtract anyway randomly, then you are likely to get some wrong answer. So your question is right. That is, what if I substitute. So okay. So let us clear out this question. What is this number? 1110 is 14. 111. So this is the first number is 9 plus this would be 16 plus 32. So just tell me what is this? I think this is 57.
57.
That is right. Now what is the decimal of this number? So this will be 1 plus 0 plus 0. So 11 plus 32. So what is 11 plus 32?
43.
43.
So 43. So what Pranjali is saying is that if you subtract in decimal, so 57 minus 43 is 14 and 5 minus 4 is 1. So what we should get is a equivalent number. So that is what we are getting. Pranjali, have I solved your doubt?
Yes, sir.
Okay. Anyway, so that's a good point that you raised, that by mistake if you take some other number, then you might get something which is not there. Fine, good. Let's go to the next slide. Now subtraction by same method, that is one's complement method only. But now I want smaller number minus larger number. So first is again determine one's complement of the larger number. So you are subtracting this number from this. So whichever number you are subtracting, you have to take complement of that number. Then again the same thing, add the ones complement to the smaller number. So first two steps are similar with the exception of word larger and smaller. In the previous case here we had smaller and here we had larger, but now you have large instead of, because you changed the order. First it was large minus small, now it has become small minus large. That is why the same thing we are doing again. So determine one's complement of the larger and then add the complement to the smaller number. The third point is slightly different. Answer is in one's complement form. To get the answer in true form, take the one's complement and assign negative sign to the answer. So Vishwas had asked question last time, what about negative and positive numbers? So either you can directly write a negative sign or you can write a 1 in place of minus, or you can write a 0 in case of plus. But since 1 and 0 are only indicative of plus and minus, for study purpose, here we represent it with only plus and minus sign. But actually speaking, in a digital system doesn't understand plus and minus. So to tell that this is a positive number, you have to append the extra 0, and tell that this is a negative number, you have to append the extra 1. So I will give you 5 minutes so that you write these steps, so that it just sinks in you. In the meantime, if you have any doubts, you can ask me. So if you have just finished copying this, just write done in the chat box. So I come to know that you have finished it. I will always be giving you some method, but then once you practice, you may not remember the method. It will become very intuitive for you. And nobody is going to ask you this method in writing in the exam. You have to only subtract and show. Okay, I can see many buns, but still I'll wait for a minute. Okay, so I'll go ahead. So let's see an example. So first write down this question. Subtract 111001 from 101011. So I have taken the same numbers but the other way around. I have taken the same numbers 57 and I think 43 but other way around. So this is what we are actually going to do. So this seems to be smaller. This is 47 and this is larger. 43, sorry. And this is larger. So what we are expecting is minus 14. What we are expecting is minus 14. So actually to determine this sign minus 1, minus or plus, we use a device called as a comparator. We use a device as a comparator. So once we know that if we are doing larger minus smaller or smaller minus larger, if we know that already, we know that answer will be positive or negative. So before subtraction, what actually we do is we use a comparator and determine whether the sum or the subtraction will be giving you a positive answer or the subtraction will be giving you a negative answer. So that is the reason why we many times don't worry about the sign and we just go ahead with subtraction. But anyway, we'll just see that. So this is my smaller number. This is my larger number. So step number 1 is complement of the larger number. So I took the one's complement and I got this. Just check whether the complement is correct or not. Okay, it seems to be right. Now you add this again back to the and tell me the answer now of this. No, the answer is not. Okay, you are telling me the final answer. One. Karthik, the sum is never going to be negative. Vishwas answer is right. But the sum will never be negative. The sum of these two will never be negative. So I'm looking at this. So here we have 1, 0, will give me a carry. 1 plus 1 is 0, carry 1. Again 1 plus 1 is 0, carry 1. 1 plus 0 is 1. And then we have 1. Now this answer that we have got is in one's complement form. That is what they are saying. When you do like this, the answer that you get is in one's complement form. So to get the right answer in true form, you have to again take its one's complement. So I am taking one's complement and assigning negative sign. So 1 is becoming 0, 0 is becoming 1, 0, 1, 0, 1, 1, 0, 1. So the final answer is going to be minus 0, 0, 1, 1, 1, 0.
So right now you said कि digital systems don't really understand science right now they're applying. So,
Right. So that's what they said that when we are studying, we just write the minus because minus means actually you can write the answer as 1, 0, 0, 1, 1, 1, 0. But then once you look at this answer, you might get a doubt whether your answer is 7-bit or 6-bit. So the confusion starts. So since this one is only indicative, we let it remain as minus. Have you understood what I'm saying?
actually, you are not really audible.
Karthik, am I clearly audible?
Sir, there are some disturbances. His voice is breaking.
My voice is breaking. Is my voice breaking?
Yeah, yes, sir.
Actually, all of your voices are breaking now. Anushka, can you try and see whether my voice is clear or is it breaking?
Kindly give me a second. Yes, now it's not breaking.
I think those who are not speaking, just put yourself on mute so that my voice will come proper. I can also hear few voices, so some people are not on mute. So please be on mute. Okay. Now the one who asked me this question, can you unmute yourself?
Yes,
Okay, who's this? Uh, who's this?
Anushka, sir.
Sorry.
Anushka.
Okay, Anushka. So, should I explain it again or what? Anushka, your voice has gone.
Hello, sir.
Yeah. So, what I said is that this minus sign is only indicative. So, even if you write the answer as 1 and then you write 0, 0, 1, 1, 1, 0, that is also fine. This can also be your answer. But then you clearly indicate here that the answer is negative. That is why this bit is 1. Why
Okay.
I will suggest you to do this is because many times when people are checking, if they skip this answer, they might just over this and actually this is your main answer. That is why you write minus this first and then you can write 1, 0, 1, 1, 0. So first you write answer is this and then you might write this as well. So once you write these both the things, I will understand that you are trying to indicate this minus sign by 1.
Okay.
So that's
Okay,
how you
thank
can
you.
write. Yes. So please mute yourself. Okay, Karthik, Anushka, is my voice now clear?
Yes, sir.
Okay. So let's go to the one, that is subtraction by 2's complement method. Subtraction is now by 2's complement method. So 2's complement means, we have already told, 1's complement plus 1. So first case will always be larger number minus smaller number. So step number 1, determine the 2's complement of smaller number. Step number 2, add the 2's complement to the larger number. So I think step number 1 and 2 are similar. Instead of 1's complement now, here we have written 2's complement. And there would always be some change in step number 3. So let us see what that step number 3 is. Discard the carry. If there is a carry, just discard it. Don't consider it. That is what they are saying. So please write down these 3 steps. Take for 2 minutes. Okay, Pratik has found out the solution for the disturbance. There are disturbances on her side. Okay, great. So that might happen because of some kind of network issue and all those things. And since we are all students of technology, I think nobody can understand this better than us. And since we are understanding it, we should try and make it, try and do something about it. So actually what happens is, just to disgrace from the topic for 2 minutes, when I am talking to you, my voice is actually getting converted from analog to digital. And through the internet protocol ID, the bits are being streamed to your end. Now what happens is, you might be in different locations and many times there might be some interruptions in the networks. So what happens is, I am sending many bits, continuous bits from your side, but you might not be receiving all of them. And even if there are some error correction codes in place, still there is some sort of limitation to that. So that is the reason why my voice actually breaks, because you are not getting everything that I am transmitting, just because of maybe poor or some kind of interruption in the network. So this is actually a problem, and today people are trying to deal with this problem using machine learning. So if we go to Zoom and take this same lecture, then the interruptions are very less, because Zoom has implemented some kind of machine learning technology in the backend to retrieve the data which is lost because of internet connection. So anyways, that's how we make business, by developing different platforms. We are on Teams, so we have to bear this platform, and this is our official platform. So should we go ahead? Karthik, should we go ahead?
Yes, sir.
Okay, great. So first is subtraction of larger number minus smaller. So large minus small is the general way of subtracting. Now you should also ask yourself a question. If I give you like 2 numbers to subtract, will you subtract smaller minus larger or larger minus smaller? So logically you will always subtract larger minus smaller only. Always you will do that. But still, many times to address things, or many times to address counts which are going below 0, we also look at the other side of the coin. So this is the question. Subtract 101011 from 111001. So again we are dealing with the same values. Just for comparison sake, this is 57, sorry, and this is 43. So we are now going to do 57 minus 43, which we should get the answer as 14. So what we are expecting is 110 again, but this time by using 2's complement method. So let us go in. This is what we have to do. That is 57 minus 43. So this is my larger number. This is my smaller number. Now, step number 1 is take 2's complement of the smaller number. So this is the 1's complement. If I add 1 to it, I will get 2's complement. So this is step number 1. This entire thing is going to be step number 1. So I took the smaller number, I took 1's complement of it, then added 1 to it, so that became my 2's complement. Now this 2's complement number I took here. So step number 2 says that add now. Add whatever you have got, 2's complement of the smaller number, add it to the larger number. So what will be the addition of this? So 1 plus 1 will be 0, carry 1. Then 1 and 3 zeros will give me sum as 1. Again sum will be 1, 1. 1, 1 will be sum 0, carry is 1. And 1, 1 will give me sum 0 and carry 1. So now step number 3 says discard the carry. Step number 3 says discard the carry. Okay, I discarded it, and what remains is just 0, 0, 1, 1, 1, 0. So this number is going to be 14. So I will write answer is 14. So please note down this in your notebook. So I am just following the steps. This is step number 3. What is step number 1? Take the smaller number and take its 2's complement. 2's complement means first you have to take 1's complement, add 1 to it. So you will get 2's complement. That 2's complement I will add it to my larger number, and I will get something. So step 3 comments on what to do after you implement number 1 and 2. So in this case it says discard the carry. So you get your answer back. Okay. So Karthik, Kanushka, have you copied this thing?
Yes, sir. Perfect.
So
What about others? Okay, great. So Atharva and Ganesh and Vishwas. Great. So I am just detailing down because not everybody might be doing this for the second time. Many of you must be doing this for the first time. So that's why I have included all the basic steps and let it go on record so that later on also you can refer to it. Okay, let's go to the next one. That is subtraction by 2's complement, but this time smaller number minus larger number. So again, what will be the first step? Determine the 2's complement of larger number. So in the previous case, we had here smaller, and step number 2, again add the 2's complement to the smaller number. So instead of smaller we had here larger in the previous case, And in the addition of carry, in the addition, if the carry is 0, determine the 2's complement of the addition outcome. So what we have to do is, if the carry is 0, then we have to determine the 2's complement. Now you might ask me, if carry is 1? What if carry is 1? That might be your obvious question. But when you do smaller minus larger, carry can never be 1. Carry can never be 1. Okay, this is a standard result, and we can see this across many examples. So we will just see that. So have you all copied down this? I think it is pretty routine, but the point number 3 is always very different in all the cases. Okay. So let's go ahead and see one example. We forgot the 4th point, that whatever the result you get, it is simply negative. You can add the 4 point in the method. So let's move ahead. So my numbers are same, just for comparison sake. Subtract, write in the question, subtract 11001 from 101011. That is using 2's complement method. So what we are going to do is this, that is 43 minus 57. So first I just write down the two numbers. This is the first one is the smaller number, and this is the larger number. Now, if you carefully read, the step says determine 2's complement of the larger number. So this is the larger number. What will be the 2's complement of the larger number? Can you post the 2's complement of the larger number? I want only the 2's complement of the larger number. Answer will be, Pranjali, answer will be minus and 14. Now we know that. But how to arrive at it is also slightly important. That is why I am asking answers for intermediate step. It's good that you arrived at that answer. Okay, so people are posting. So let's see how they have got this. Common answer I can see is 0000111. Good, Shruti, Mitali. Great. So this is the complement, that is the 1's complement. Now if I want 2's complement, I'll add 1 to it. I'll get the 2's complement, that is 00111. Now this 2's complement I will add with the smaller number. Now I want the answer of this addition. I want the answer of addition of these two numbers. So now this entire side is step number 1. Now we are looking at step number 2. So tell me the answer of this addition. Okay, great. Prathamesh Satam has answered it first. Okay, so the answer is pretty simple. 1 1 is 0, carry 1. Now again there is a case of 3 ones. So the addition of the first two ones will give me a sum of 0, which if I add with again 1, I will get here 1. But my carry also will be 1. Then 1 1 is going to be 0, carry 1. Again 1 1 will be 0, carry 1. 1 plus 0 will be 1. And so the answer is going to be 110010. Now step 3 says that if carry is 0, determine the 2's complement of the addition. That means now I want to know what is the 2's complement of this. So now let us go at step number 3. So now I want you to calculate 2's complement of 110010. Okay, great. Vishwas has given the answer. The first one to answer. But let's see how. So 2's complement means first thing is carry is 0. So this is going to be the 1's complement. So to take 2's complement, first you have to take 1's complement. This is 1's complement. And then when I add 1 to it, I get 2's complement. So whatever you get here after adding, you will get only this, not get minus sign. But step 4 says that the result is negative. So the answer will be minus 0011110. Dhruvali, Shruti, Anushka, that's right. But your answer will be minus of whatever you have got after you consider step number 4. That is great. So I want to highlight one thing about subtraction. So you all should note this down somewhere. Just a minute. So something about subtraction, okay? Just a minute. So just note down these critical points about subtraction so that you don't have confusion in your mind about what is getting subtracted. So let's say we have two numbers, A and B. Let's say we have two numbers, A and B. We don't know whether they are, which is greater and which is smaller. So first, when you actually enter two numbers inside the system doesn't know difference which is smaller. So what it does is it uses a comparator. It uses a comparator. So comparator gives me three outputs. The output will be 1, if so if A is greater than B, then maybe this will be 1. Then if this is 0, 1, 0, that means probably A is less than B. And if this is 0, 0, 1, then that would mean A is equal to B. So what we do is, before we subtract, we determine which is bigger, because our subtraction starts from the step subtraction of smaller minus larger. But my question is how to actually determine smaller minus larger. So Anushka and Karthik, can you hear me?
Yes, sir.
Anushka, your voice did not come proper. Is my voice proper?
Yes, sir.
Yes.
Okay.
So your voice is proper. I think problem is on her side.
Okay. So this is what we determine first. Now, naturally, why do we do this? We do this to take an estimate whether my answer is going to be positive or negative. So let's say if A is larger and B is smaller, we know that. So system will find out A is greater than B, then that means the answer is positive. And if A is less than B, that means the answer is negative. So we already know before the subtraction itself whether my answer is going to be positive or negative. We know that. We know that means what? We know what to append to my answer, whether it is 0 or 1 after I actually do the subtraction. Once I know these values, now what I do is I give two inputs again here, that is A, B, and whether the answer is positive or negative to the subtractor. Positive or negative means whether it is 0 or 1. Then subtraction will happen with 1's complement or 2's complement, whichever method you write, and then you get some answer or some value. Now you saw that in all our cases our final answer was 14 only, but the question was always whether it is positive or negative. So this value which I get, whether it is positive or negative, is given by this third input to the subtractor, which is actually the output of a comparator. So we already did some pre-processing and determined whether the value is positive or negative. So this part is actually not there in the books. They don't write it very clearly, but when we do or implement a subtractor on FPGA design, we always do comparison first and determine whether the answer is going to be positive or negative, and then do the subtraction, and we know whether the answer is going to be positive or negative, and then accordingly append the sign. So those who asked me questions about the sign, in all the methods it is simply written result is negative. Why result is negative? Because we already know that result is going to be negative. How do we know? Because we have already done some kind of comparison. So nothing is magic. So to determine that which is bigger than what, we have already used a comparator before, but no books will write that. So that is why we can directly write that the answer is negative. Have you understood this small point? So if you have understood this, just type a yes in your chat box. Okay. I can't see you. Okay. So what we'll do now is we'll just take a break of 15 minutes and come back and start coding techniques. And just a minute. So there are 70 students. Okay, so just let me take down the attendance for the first session. Nobody should log out. Okay, so we'll take a break of 15 minutes. So you all can just go and have some coffee or tea or probably have some snacks and come back in 15 minutes. And the next session will be of around 30 minutes with a discussion of 10 minutes. So thank you. Anushka, Karthik and Kashmira,
Yes, sir.
we'll be back in 15 minutes.
Yes, sir. No problem.
You may not log out. You may just simply leave your system and just come back after 15 minutes.
Okay, sir.